they approved the project and they provide the funding. From the funding, we bought the project and the scanner, and we are very thankful to them, and hopefully it will be used for the multi-purposes. So this is our research team, and we submitted our proposal to Deanship of Research for Tamayus 2, and I am the principal investigator for this project, and Dr. Shekhzod Takirov is working at in the University of California, Berkeley, and he has a lot of experience during his career for laser scanning. He did a lot of laser scanning for the mosque, for historical structures, for the structural experimentals work. So he is one of our consultants working in this project. Then we have the research assistant engineer Wahab. He is also supporting us. And the fourth one is Dr. Wadia Sindhi. He also did some laser scanning on the old device, which is from Leica. We are using the Faro. So he also shared his experience about his bridge load test done in Michigan, and also his master thesis is related to the laser scanning of the some sport complex. So he also shared some experience and advised us about the project. And the other teams includes our students. So they are working on their senior design projects also, but parallelly they are also working on the laser scanning. So we are thankful to Muhammad Zubairi, Umar, and Yasir, and Munir. They are also supporting us in our project. So what is the laser scanning? Actually, laser scanning, we have the laser scanner, which rotates in horizontally, vertically, and straight in the straight direction, and have some laser beams, and to get some point clouds or scans for the buildings, for the large structures. And for where the structure height is very high, we cannot reach. So laser scanning is one of the good solution to do to get some data or some analysis from those laser scanning device. Actually, it's also called the LIDAR scanning, so light detection and ranging scanning. LIDAR is one of the new application used in structural analysis, investigation or detection of the cracks or some failures. So LIDAR is scanning also one of the latest technology, which was first used in 2017. Also one of the pioneer in this LIDAR technology. He did a lot of bid survey in University of California, Berkeley, and a lot of study he has done. Then we have high-speed lasers. From high-speed lasers, we can get the data of the buildings, and they are very lot of points we can collect, like 1 million points we will collect in second, which is called the point cloud. Point cloud is basically, these are the points. Our data is a dense point they are making, and from point cloud we can make and the building model or building analyzed from the point cloud data. We can also collect the geometric data for the particular structures, and then precisely we can register in the software so that we can get some model. So this is real-time data. It's reduced site visits, and it's we can get the immediate results within a few minutes. Scanning time will take 5 to 8 minutes, and then 3D visualization is very easy, and we can dimension the buildings easily. It's very fast and very easy to get the data. So this is showing how the laser scanning works. So actually, we target some buildings or some structures. Then we apply the laser scanner on the tripod or even on the handheld. Then we run the laser scanner. It will reflect the structure, and it will rotate in the three dimension. Like here you see in the picture, in the distance, in the vertical angle, as well as for the horizontal angle. So it will collect all the data in all directions. So that's called it's a 3D laser scanners. And then we have the LiDAR is same like we have the LiDAR and we have the object here, which will have the laser beam on the object. So we fix the scanner on the tripod, and it's also called a static terrestrial setup. Yeah, terrestrial survey, terrestrial scanning. Because we have to collect the data like in Google Map or something, they collect the building data. That is an aerial survey, okay? But we are doing the static scanning. That means we set up the scanner on the Earth. So this is called a static terrestrial setup scanning. So this is showing the different laser scanners. Different. We are using also small laser scanners. Like in our labs, the mechanical faculty is using the small laser scanner for detection of reflections, or small laser scanner for the 3D printing. But our civil engineering structures are very huge and in large quantity. So we have to focus on the large scanning area. So they change from the laser line to the hemispherical laser scanner, or hemispherical laser scanners, or long range laser scanners. Okay, so we are using the large range laser scanners, which can be more than 10 meter, or it will capture the image more than 300 meter. So the scanner which we are using is about 150 meter in our range. It will capture whole data. So this is showing the conventional measurement. So it will take 1 point will take 5 seconds, and it's very slower. But if we use the laser scanner, it will take 1 point and 1 million point in 1 second. So it is very fast, and it is will require the less people. But another conventional measuring scanning will need more device and more people. Like here we can see in the bridge. If we use the conventional devices, we have to take so many points to make a bridge structure to see the bridge. But if we take the scanner, it will we will see within 8 or 5 minutes the whole structure, and we can model and analyze the whole area within 10 or 20 minutes. But if we use the conventional device, it will take more time. So this is the typical laser scanning statistics. So it will take less time, and conventional instrument will take more time, maybe 3 or 4 weeks, and we can immediately deliver our results or drawings within 1 week or within 2 or 3 days immediately. And we will check the monitor the structures easily. This is one of the building structure, another is showing the bridge structure for the laser scanning. Well, there are so many laser scanner devices are available. So once we are submitting our project, so we go through so many different exercises, so which laser scanner we should buy. So we decide this Faro laser scanner, and there is also another competitor for this company is Leica company. So they have also very good like quality scanners, but there are advantage and disadvantage for each of them. So we prefer the Faro because it's very lightweight and it will take more clouds, 1 million cloud points per second, and maybe Leica is not as a capacity to take more points, and it's a very heavy. Maybe the Faro scanner will take 7 pounds weight, and Leica is more weight. So this is simple comparison of the two scanners, like we can see here. So this will take the 1 million points, and the cost is also very less in Faro, and here then the Leica it will take more times. So it will take the more also huge work, or some huge some other like supporting work, so which will take care automatically by the Faro scanner. Here we can see compare the two. This is very heavy and this is very small scanner and the size. So we can also use it and handheld, and we can keep everywhere where we need it. What is the advantage and benefit of the scanner? So it's very data is very controlled, and we can assure the safe collection of the data. And safety is also very important while doing the scanning, because it's have the very confined spaces, and we can use it the busy roads, and it will easily, we cannot disturb the other activities during the scanning activities. Also take the whole missing data, so it will easy to get data thoroughly, and we will connect the data, and we will not miss any data after scanning. And we will use the whole traditional data. It's very difficult. So we will have the point cloud dense data. Even we get whatever we require, we can get more data from the scanning. And we will not go again and again to get more data. Once we capture the image, we can use for multi-purposes. So it's reduce our time, and we also, it's high visibility and realistic models. And also we can rework or reuse our data, and we can have the fewer site visits, and we will have the better information management by using the scanning. And we can use in architectural purposes, transportation purposes, aviation, building construction, bridge design, and there are so many applications of the laser scanning. And if we are working on the project, so we can start from beginning of the project till the end of the project, we can have the data so that we can use it from the concept phase, design phase, development phase, and implementation phase. So all data we can get from the practical construction sites. Like building information modeling means the building is under construction, which is all the activities we can capture through the scanning in this development phase. So these are different type of scanners used. So one is Faro, another Leica. There are other also scanners. So they are also used for multi-purposes, and there are different applications for the laser scanning, including civil engineering, digital modeling, inspection and structural analysis, geological, city planning, architectural, archaeological, like heritage conservation, preservation, crime scene preservation. Also, they use forensic analysis. They use the laser scanning, land surveying, digitization, reverse engineering. Like we have model and we want to make the reverse engineering model, we can make it from the laser scanning. And the visual animations. So they are very good to capture the data, and we will do apply so many fields we can apply there. For civil engineering, mostly we use for the facade inspection or front inspection, for the structural analysis, or for the construction progress. Like this is under construction building, we will see different activities, or from the deformation controls or the stress analysis, we can use it for civil engineering. Even we can use it for building information and modeling, and also for used architectural purposes. So this is real world application, and we can use the build documents for the existing construction sites, or the big projects, or big even the old construction site or historical construction site. We can use it for the construction, facility management, heritage, and real estate purposes. So this is another application of the bridge engineering. So here we can do the scanning for the large distances, because the bridge is a very big model. This is showing the suspension bridge. So it's we cannot do capture the data. So for laser scanning, within 3 or 4 scanning, we can get whole model for the bridges. And this is showing the landslides, or this is showing the different bridge views or surrounding areas. We can capture all those informations. Heritage and archaeology, we also use it for the reconstruction of the old houses or historical houses, restoration or conservation. So it is very good application. Even for the existing facility and asset management, or like real estate like industry, we can also use for documentation, planning, and replanning of the technical modifications. For reverse engineering, like we have the model, so we capture this model and we make a 3D model, and we can make a prototype, and then we can print it in 3D printer or something to make the original reverse engineering model from the existing models. Shipbuilding, this is also one of the application of the laser scanning. So we can repair the ships in the industry. Then this is the process industry, and like pipeline or petrochemical industry, we can also apply here. Or even the forensic analysis like the accidents or for some other type of activities, we can also use it for the forensic purposes. From crime scene investigation and analysis, we can use it. So this is also used for the tunnel, and in Makkah region, this is the tunnel. There is one international company. They did the laser scanning for this tunnel, and they also continues this work. So this is one of the good application to use tunnel and mining for the real world applications for the laser scanning. So actually, so first we have to go for the select the target, means some structures, and then we have to do some scanning results, and then we can capture the data, and then this is whole area where we do the analysis, and then we clip some areas which are not interested. Then we make a model for that point clouds, like this is a bridge model or bridge model. So then we will only model this area, and we will ignore all those other things. This is showing the collapse of the bridge. So this is showing the point clouds of the collapse of the bridge. This bridge was damaged due to the earthquakes. And this is also the landslides of the bridge, which was also happened due to the earthquakes. And this is also doing the point cloud laser scanning results for the scanning for the results. This is one of the Dr. Sheikh Saad, which is our consultant, did some scanning for the madrasa in Uzbekistan, Samarkand. So this is showing his results. So and this is showing the inner view of the laser capture for this historical building. This is another application of the laser scanning in onshore structures. Then we have the land survey. Then we have the construction, under construction bridge, and this is the heritage building. We can do the, this is showing the point cloud data for those structures. Actually, scanning process, first we have to target the structures, then we have to capture the point clouds in the software, then we do the 3D model, and then we do the 2D drawings, and then we do some analysis. So this is the scanning process, this is the pipeline project targeted. And then this is the different scanning positions we did. In this project, we did the 6 scanning positions in the different locations. Then we registered it in the software. So point cloud, then we make a 3D model, then from 3D model, we will make the real construction drawings and models. So this is showing the 5 scans together. We collect all the scans together, then we will make the real model for the whole area. This is showing the converting the 3D model into the drawings. So and we can visualize everything inside the models. This is virtual, and we can also go inside the model and see every details clearly. This is the scanner. We put on the stairs and we collect the stairs data from this. And this is one of the hospitals. We did this laser scanning for the hospital area, and we check the deformations and the floor levels and other activities inside the hospital. Well, so I will explain you the one case study we did recently for engineering college building, because 3 weeks or 1 month before we got the equipment, and we did one case study. Inshallah, we will do the more case studies. We did this case study engineering college building, and these are documents we use. We have the laser scanner here, we have the software, and this is the laser scanner on the tripod. So the laser scanner rotate in different angles, and this is the setup. We have the parameters, and we will finally run the scanner. It will rotate in different direction and capture the data. And these are the targets. Like in 1, 2, 3, these are the checkboard targets. We put 7, 8 targets in E2 buildings in front of the engineering college buildings, and then we get the targets. And then we have the scene software, which will capture analyze the data. So first we scan the data, then we make the registration, or we then extract the analysis, then we finally make the 2D or 3D models. So these are the steps we have done in our model. First, we scanned this college, engineering college building, then we make a point cloud, then we made the 3D model, and from 3D model, we convert into the architectural and the structural drawings. And these are the checkerboards we put on the buildings in front of the E2 buildings. There are 7 or 8 checkerboards, which will measure the targets inside the scanning. So it will easily connect the 3 or 4 scanning points together by using these checkerboards. So these are the 4 different locations, scan positions in our building, scan position 1, 2, 3, 4. And finally, we register it in the data and combine the whole data together. So we complete our scanning process, then we use the software to analyze our data. Then in software, we use the Scene software, and Scene software is very good to combine the scanning positions together. And finally, we will make a model from the scene, through the Scene software and export in different programs. So Scene software actually worked. So first we did the project scanning data. We import the 4 scanning as we did for the engineering college building. Then we process the data. We will have registered. So and then finally we have the combination of all the scanning data. We have the real model, and then we make the real model for the structures. So this is showing the project. This is the open. We already finished this project. This is open. So this is showing the project we have opened in the Scene software, and then we open this new project, and we just then we need to process for import, processing, registration, explore, and export. So we can import the, we did the 4 scan, like we see model 1, model 2, 3, 4. So there are 4 scanning, and finally we import the data and we can process it. After processing the whole, it will combine the process for whole data and make the combined project for the E2 building. And then we have the registration here, processing, and it will process all our scan, 4 scan data, and then finally it will do the registration. So in registration, we have the manual registration, we have the automatic registration. Automatic registration, it will automatically combine the 4 scans, and then it will make a model. And it will also consider the checkerboards, the targets we place on the wall, and it automatically convert into the new the original model. And manual registration takes some time. So basically, for the large projects, manual registration is better. For the small projects, automatic registration is better. And once we register our buildings, so different scan, we combine the different scan together with the help of the checkerboards. And then finally, we place the targets to combine the 2 different scanning. We have the 4 scanning, so we combine the scan 1 with the scan 2, scan 3 with scan 4, so that we can capture the whole area easily. Then we explore it. Explore, we can see the registrations, dimensions, everything together. So it will be easy to analyze the 3D model. So we take the measurement of the height of the building, so which is very accurate, is according to our drawings or according to our model. And this is also showing the 3D model which we made for the from the 4 scans. And finally, we export our data into the different programs like AutoCAD, VCAP, and Autodesk, Revit. So this is showing our model in AutoCAD, and this is showing our model in Revit. So finally, we got the point clouds. From point cloud, we converted into the architectural drawings, and we did some office work or analysis for 3D modeling. And after getting the modeling, we analyze into different structure analysis softwares for the 3D model, for the stress analysis, for the shear force bending moment diagrams, or for the deflection analysis, for the earthquake analysis. So this is the showing the different results from the structure analysis programs. So we acquired the 3D data, then we registered it, and we visualized our model, and finally we export into the AutoCAD, VCAP, AutoCAD, and SAP 2000 models. So this is our dedicated team. So we have the students, mashallah, they are working very good, and they are supporting. And we have 3D models we are analyzing on our computers. And then we have also several structural experts. And we hopefully we will do more projects in Medina. So this is one of the umbrella projects. This is some of the wall arches Masjid Nabawi, and this is the mosque analysis. This is showing the analysis result. Still, we will do the scanning for those projects, and hopefully we will do some 3D printing also. And this is also the bridge models we will perform in the Haramain railway station, one of the bridge of the Haramain railway station. This is showing the model we already finished, but still we need to do scanning. And this is some overhead bridges on Tariq-e-Salam Road. We will also do other projects in Kingdom of Saudi Arabia, including in Jeddah and Makkah region, and also historical structures in Ulala region. We will hopefully, if we have time, we will do some scanning there. So laser scanning makes dreams come true. So we will really capture the real model easily. So this is a transparent system that benefits the company projects and its stakeholders. So it's a very beneficial for the industry, for the complex projects, can be scanned easily, and its very efficiency is high in performance and very time saving. I think I finished my presentation. If you have any questions, you can ask me. Thank you very much for everyone.
Can I ask Dr. Bhatti?
Yes, please.
Okay, I'm Suhail from Mechanical Engineering. Thank you very much for your presentation. My initial job was scanning parts, and I use Ferroarm and Konica Minolta, so this topic is very close to me as well, and I really thoroughly enjoyed your presentation. I have few questions. What is the resolution of this scanner, the scanner you are using? I mean, what is the distance between point to point?
Point to point is very minimum. I think it's a micro or something. They know it's very high resolution. Actually, I don't know exactly what is the resolution, but in the slides I mentioned here.
Yeah, I saw the much detail, but the resolution is, I mean, it will define the.
Like in mechanical, the small scanning we use very less resolution.
Yes,
and
exactly.
For the large we use very high resolutions.
Okay, so my second question is, maybe we can discuss this resolution thing later on. You showed most of your in the front view. What about if I want to scan the building from the side view as well? So how do you merge the data, front view and side view, to get the whole building view? For example, most of the pictures you showed is just like one side of the building.
Yes, we can. We did the scan capturing for different size because we have did for here for 4 scans. Okay, like here we did 4 scans, 4 different views here, and 4 different views we can get the 3D diagram for this for the 4 different views. But actually we are only interested in the front model because we have analyzed this front model with our softwares. We can capture all the. It's rotate all in all directions. It's not only rotate in the front view. It will rotate in horizontally, vertically, as well as like here you can see 3D view. So here it will capture all the 3D views and for the different positions. This is one of the scanning position showing here, but there are 4 scanning different views. So we can combine the all scanning together. It will give the complete 3D view of the structures or buildings.
All right, when you combine the data, the origin becomes very important. So I see the checkerboard pasted.
Yeah, checkerboard, this is the origins. We will target those checkerboards to confirm our origin with the location where we get the scanning data.
Okay, my question is that the checkerboard is not on the building which you are scanning. The checkerboard is on other building. So is it just for the origin, for the camera location origin purpose, or the checkerboards are?
Actually, you are confusing yourself because this rotate in the horizontally, vertically, even at the bottom of the ground. So it's rotate in the all 360 degree. So it will get all the data on 360 within 150 meter range. Whatever is coming within 150 meter range, it will take whole data. But it's better to take more scans for the accuracy of the results.
No, my question is that the checkerboard is not attached on the building you are scanning. It is attached somewhere else. So what is the origin?
Yes, the origin is where we will get the scanning. These are the target points, so that we can combine the different scans positions together. by using the checkerboard locations targets.
All right. My last question, I'm taking too much time. Last question. How much roughly these scanners would cost? Just a ballpark value, if you like to quote.
Actually, it's Leica is costing 500,000 riyals, and Faro they did discount with us, and for the academic discount, the scanner which I have also in my office. This one you can see. So this is around 300 riyals, 300 lakh riyals, 300,000 riyals. But we bought it in 150,000 riyals. Yeah.
Okay, so you got a discount, right?
Yeah, we got a lot of discount from them because
Very
they are also interested in our research. So they say we will just for your research, we are supporting you.
All right. Thank you for your presentation.
Okay, thank you.
Assalamu alaikum warahmatullahi wabarakatuh, Dr. Bhatti.
Yes.
Actually, I have one question which is also in a way asked by Dr. Sohaib. What about, for example, top view? How do you require? Don't you require top view as well? And if you require, how do you cover that? For example, through drones, or I mean, or you are not interested at all?
Yes, top view, if we go to the roof level and we will do the scanning of the roofs, it will connect automatically by using the checkerboards. And we will do some targets, and then we do the separate scanning, and then we will connect this corner, the top view, it will automatically connect the top view. Before doing this, we have another sample projects we did for the lab, our lab scanning of the inside view of the lab. I don't have time, so I will show you. But inside, it will capture all inside the view of the labs, even inside the view of the rooms. We connect the one room with another room, like our ground floor of our engineering college building. We capture all the data and connect all labs together. And it's connecting everything inside because there are two types of scanning. One is indoor scanning, and another is outdoor scanning. So we can do both.
So subsequent question is, for example, if you have a densely crowded place, for example, you just have access to front view and you cannot cover side views and the back view, then in that case, what is the credibility of your scanning? Is it like still?
Yes, we can, like we have the point clouds. If some points we are not interested in software, we can remove it. It's very easy. Like in the front view of this building, there are electrical poles or some sign posts which are not interested in our structural analysis or 3D analysis. We remove it in actual models. We can do it.
Okay.
It's not so difficult.
No, my last question is, for example, if you have a building with structure only, no fillings, just structure, steel structure, let's say.
Okay.
So how the scanner differentiate a building just with steel structure and a full-fledged building?
Actually, we apply this type of application in the building information and modeling. Like our stadium in our Jamia Islamia, there is a stadium. This is under construction stadium. So there is not complete structure. We can go inside and scan all the elements, or the sizes and everything. We can collect building information and we can model it according to the existing conditions. So it's also one of the applications of this scanner for building information and modeling.
So Dr. Bhatti, sorry, I keep asking. The final question is, you scan already existing structures, right? So how does it help to redesign something new? For example, what do you predict about future design of buildings? Does it provide any help, or it's just scanning things?
No, because some structures we don't have the data. We don't like the bridges, we cannot go and collect the data easily. So we can easily collect the data for the existing structures. And even we are planning to do some old structures, which is the data is not available. So it will also helpful to provide some data and some structure model for those buildings as well.
Okay, Jazakallah. Thank you so much.
Okay.
Hello, Dr. Bhatti.
Yes.
This is Mohyuddin. What about the underground structures, underground parking and all? Can we able to scan with your device?
Yes. We can go underground and we can scan all the parking locations, parking area. There are so many studies also done by using laser scanning. for the parking structures or underground structures as well. Yes. So inside the parking, we can locate all the information or some spaces, everything management. We can do it by using the laser scanning as well.
Thank you.
So any more question?
Yes, any questions from the participant? Hope you all enjoyed the presentation. Okay, thank you very much for your participation. Thank you, Dr. Bhatti, for your participation. Jazakallah khair.
Thank you.
Assalamu alaikum.